Together with my colleague Prasad, we will present you the vCloud API. My name is Vasil Popovsky, and I'm leading the development team that is working on the vCloud API in VMware. Well, this is the standard disclaimer that you are seeing with every session. I'll move forward. Today we're going to present a few things. I'll talk about the need of the vCloud API. Also, we'll introduce some of the key concepts and constructs in the vCloud, and we'll talk about these constructs in the API. Prasad will talk about the SDKs, the vCloud SDKs, also the use cases, and he will talk about user-centric and service provider-centric samples. We'll cover a lot of things today, so may I ask you if you have any questions to keep them by the end, otherwise we'll not be able to finish our presentation on time. Why we need the vCloud API? We have a number of ways to create applications. Applications can be created by developers, by ISVs, framework vendors, or cloud application providers, or this could be existing applications. But once we have these applications locally on our local storage, that described with this OVF, which is a standard now. And we have these applications on our local storage, and we may want to move the applications from our local storage to the private cloud, or move the applications from a private cloud to a public cloud, or move applications between two public clouds, or download applications from public cloud to our local storage again. And in order to do all these things, we need an API. And this API must have following characteristics. It should support federation, or ability to move workloads between clouds. This API should be based on open standards. This API should have a common tools for managing both private and public clouds. And existing applications should continue to run in the cloud. There should be no need for rewriting these applications. And the answer to all of these requirements and all of these needs is the vCloud API. Very short definition of the vCloud API. Basically, it is an interface for providing and consuming resources in the cloud. In addition, with the vCloud API, you can deploy and manage resources in the cloud, and also the vCloud API support federation case where you can migrate workloads between different clouds. The vCloud API is pure virtual, meaning that physical infrastructure is completely hidden. Users of the vCloud API work only with resources, and they usually don't care where these resources are located physically. The REST API is also standardizable, meaning that it is platform independent and it can be implemented by anyone. We basically submitted the vCloud API a few months ago to the DMTF group for standardization. This is the group that standardized OVF. The vCloud API is based on standards. We use REST. HTTP is the transport protocol. The object model in the vCloud API is defined with XML and XML schema, and we leverage the OVF. Applications to the clouds using the vCloud API are basically described with OVF, and we also utilize some of the existing OVF sections for configuration and reconfiguration of virtual applications. Now I'll talk about what are the key constructs in the vCloud, and I'll start with VM, which is basically a virtual hardware box. This is a virtualized server. But for modern applications, a VM is not enough to describe the complexity. Usually, modern applications consist of more than one VM. And that's why we have another concept, which is VApp. And VApp is basically a set of one or more VMs that are encapsulated, and that we have defined deployment environments for them. And VApp is usually distributed and described with OVF. One example of a VApp is a modern web application that consists of a database, application server, and a web server. Here in the example, we have Oracle, Tomcat, and Apache. VApp allows you to define a network topology. In this example, the green network, this is an isolated network that connects the 3 VMs that we have in the VApp. Isolated meaning that this network is not accessible from outside. We also have external network which is accessible from outside, and this is the entry point to our application. This is the Apache server. In addition to networking, there are also a number of things that are available as policies for VApps. For example, startup order. We may want Oracle to start before the application server. Also, there are additional things like resources, like the lifetime of the VApp, when it will be decommissioned, and etc. But VApp itself, as a construct, needs a place where it can run. And this place is called virtual data center. Basically, virtual data center is a set of resources. It is a set of memory, CPU, storage, and network. Also, there's a commodity of these resources. There's a certain SLA. And virtual data center as a construct also is not enough. That's why we have another concept that we call organization. Organization basically is a top-level container. It is a unit of multi-tenancy, and in one organization you can have multiple virtual data centers. And in one organization you can define policies for the users in this organization, and in addition to that you can assign roles and rights to the users in the organization. Another concept, this is a catalog. A catalog is basically a place where you can have predefined software solutions. And these predefined software solutions can be VApp templates, which are basically a blueprint for VApp. You can take a VApp template and create a VApp from it. And the other possibility is ISO images or virtual floppies. And catalogs can be shared between different organizations, meaning that if you have a service cloud provider, the cloud provider can share a catalog to all of its customers in order to access a common solution. For example, LAMP stack can be one such solution that can be distributed by the service provider. All these things, all these concepts that I presented, they are currently available in the vCloud director that we released this week and we announced on the keynote. I will not focus in details what vCloud director is, but the vCloud director is also implementing the vCloud API. Now I'll return back to the vCloud API and talk about the different concepts and design choices that we had. And I'll first start with REST. We decided to use REST because of a number of reasons. REST is basically a stateless protocol, meaning that when we use REST, we can implement servers that are very highly scalable. Then REST is simple. Compared to protocols like SOAP, there is no such complexity with additional payload that this protocol have. Then REST, it is based on HTTP and HTTPS, meaning that we have a number of tools that are already there that can talk to HTTP and HTTPS and can be reused. REST is extensible, meaning that you can add new operations and new data types very easily. REST is widely adopted. Last time when I checked what is the ratio between REST and SOAP interfaces, it seems that REST is currently winning 3-1, all for the new web services that are introduced. And also REST does not require any additional discovery mechanism. You can start from a root resource and you can go to all of the resources that are available in the system. And I'll talk about this a bit later. Then being a REST API and being an API that is based on HTTP, we, of course, reuse the meaning of the HTTP verbs. And for the vCloud API, get as an HTTP verb is used to retrieve the representation of a resource. Put is used to update the resource. Post to create a new resource, and delete to destroy a resource. In addition to that, we also use post to execute an action on a resource. For example, if you want to power on a VM, this will be a post operation because this is an action. This is an action on the VM resource. Moving forward, when you're talking about the vCloud API, we basically have three APIs in mind. We have the first two, the user API and the admin API. These are pure virtual APIs that are standardizable and that are product agnostic, and they can be implemented by anyone. They can be implemented on the top of Zen or the top of Hyper-V. This APIs does not expose any VMware-specific details. The first one, the user API, it is focused on self-provisioning, and it leverages OVF for VM and VIA pre-configuration. The second one, the admin API, it is targeted to system and org administration. In addition to that, we have one more API, which is the admin API. The admin API, it is VMware specific. It exposes VMware concepts. This API is built using the extensibility mechanism that we have in the vCloud API. These admin API extensions are targeted to managing the administration of the VMware vCloud director. Then I'll talk a bit about the different APIs. The user API, as I mentioned, this is self-provisioning, and the user API allow you to have access to following entities, to organizations, VDCs, catalogs. The two other entities that I haven't talked about these are org networks. Basically, org networks are networks that are available to one organization. These networks can be facing external, facing internet, or they can be isolated to this organization, or they can span multiple organizations. Then another entity that I haven't talked about, this is task. Task is basically a long-running operation. Certain operation in the cloud are long-running, meaning that after you execute them, you cannot get the answer immediately, and there is certain time that should pass in order to finish the task. For example, cloning a VM. This is a long-running operation that can take more time. Then the user API, it supports CRUD operations for VApps, VApp templates, and media. In addition to that, catalog items. Catalog items are basically items that you can put in catalog that contain some metadata for VApp template and media. And if you look at the model, this is a very simplified model of the API, of the user API. And for those that are not familiar with the UML notation, I will use this notation, it's called composition, to represent a whole part relationship where the part is exclusively owned by the whole. And in this example, organization is completely owning VDC, meaning that VDCs cannot be shared between different organizations. Also, VDC completely own VApps. Then I'll use this notation, which is called aggregation, to represent a group member relationship. And members can be shared between groups. On this simplified model, organization can contain org networks, and these org networks can be shared between different organizations. And I'll use this UML notation, which is called association. Basically, this is one-way association. And in this example, the VApp has association to network, to org network. Basically, this is the networking. This can be external network, or this can be isolated network. I'll talk about this a bit later. And if I go and expand this model further, the full model for the user API is as you see it. On the top, we have the catalog. The catalog contains catalog items. A catalog item is basically a reference to an entity in the system. For vCloud API 1.0, this entity could be only VApp template or media. Then VDC. In VDC, you can have multiple resource entities. And resource entities, they can be VApp templates, media, or VApps. And VApps can contain other VApps or VMs. For vCloud API 1.0, we don't allow multiple nesting of VApps, meaning that one VApp can contain only VMs. VApp also have a VApp network, which can be bound to organizational network, or it can be isolated. VM can be connected to a VApp network, and VM has a connection to media, which could be CD-ROM or floppy. On the slide here, entities that are marked in orange, they're read-only, and they cannot be accessed by the user. They cannot be modified using the user API. And in order to modify these entities, we have the admin API. As I mentioned in the beginning, the user API is fully focused on self-provisioning, meaning that when you're self-provisioning, the VDC org network, organization catalog, all this is granted to you. You don't care about how to modify these things. Admin API. Entities that I haven't talked about, these are provider VDC and external networks. Provider VDC is basically, this is Uber VDC, which can be used to create another VDCs. External network is similar to that. With you can create org networks that are associated to external networks, or org networks can be isolated. Then admin API provides CRUD support for organizations, catalogs, VDCs, and org networks. The other three entities, roles, users, and groups, I have not included in this slide for simplicity. And again, here, if you can see entities which are marked in orange, they're read-only, meaning that they cannot be modified by the admin API. Because usually external networks and provider VDC, they're bound to physical resources, meaning that these things are implementation specific. And that's why we have the admin API extension, which is basically the VMware specific implementation for administrating the vCloud director. Admin API extension allow you to register and unregister virtual centers to vCloud director, also to import VMs from virtual centers, and provide CRUD operations for provider VDCs, external networks, network pools. Network pools and hosts are, again, not included in this slide for simplicity. And here on the slide, you can see what is the relationship between the objects and entities that we have in the vCloud director and entities and objects that we have in vSphere. And respectively, the entities, there is a match between the vCloud API and Vim API objects. And provider VDC, for example, provider VDC is created from multiple data stores and one resource pool. And when you create an org VDC from a provider VDC, basically this is a sub-resource pool of the resource pool that provider VDC is using. Similar to that, external networks, they're basically port groups in the Vim API. Talking about different API versions, 0.8, it was released to public in the summer of 2008 and 9. It was implemented by vCloud Express partners. Then after that, we released 0.9, which was released as part of VMware vCloud Director Beta. This was in spring 2010. The differences between 0.9 and 0.8 is that the second adds the 0.9 adds extensibility mechanism, and also polish some of the concepts that we have in 0.8. Then 1.0, it was released as a part of VMware vCloud Director 1.0 this week. It is a polish of 0.9 plus, and there is no big conceptual changes compared to 0.9. I'll talk quickly about some of the general features that we have in the vCloud API. vCloud API, being based on HTTP, follows the standard HTTP response codes, meaning that 200 response codes are used to indicate that the operation are successful. Then 400 response codes are used to indicate that there's a user error, and 500 response codes are used used to indicate server errors. Then, in case of error, the vCloud API provides a standardized element that you can use to retrieve more information about what is the root cause and what is the reason for the error. We provide a message, which is basically a user-friendly description of the error, which can be localized. We have a major error code, which is basically the same as the HTTP status code. We have minor error code that provide some additional information about the error. For example, if powering on a VApp is failing by some reason, this can be provided in minor error code. In addition to that, we have two more vendor-specific error code that is basically a vendor-specific implementation that can be used to point to a specific model or part of the code in order to diagnose the problem easier. And we have a stack trace, which is basically Java or other language stack trace. Then, when I mentioned in the beginning that the vCloud API and the REST API does not need any discovery mechanism, this is what I really meant. We have URIs, and URIs are opaque. All resources are basically identified by URIs. In the representation of the entities, we include links to other resources and also to operations that are available to this entity. For example, here we have a virtual machine. Virtual machine is, we have a link with the relationship up, which is the VApp that is containing the virtual machine. Then we have link with the relation power on, meaning that this VM is in powered off state. That's why this VM does not have a link to power off operation, because this operation is not available. Only power on operation is available. In addition to that, the user that has retrieved this VM has a permissions to edit and remove this VM. Thus, the user see links for edit and remove. Then, as I also mentioned already, we have a long-running operations, and in case of long-running operation, we return task. This task can be used, the client should poll the task from time to time to see if the task has completed or not. For the task, we have basically a start time, what is the operation, what is the status which can be running or finished with success or finished with error. And in addition to that, we have owner. Basically, owner is the entity that started the task. In this example, this is VApp, meaning that we did a power on a VApp. And this is the entity referred here. Then the API has a login mechanism. And the login mechanism is that the user that is using the API first needs to log in. When the user log in, it obtains authentication token. And for all further requests, this authentication token will be used. We designed this that way because currently we do support only HTTP, basic HTTP authorization, but in the future we may support some other ways like digest or client certificates, and we don't want to change the way you're using the API. What will change is the entry point. What will change only is the login. But once you retrieve this authentication token, it doesn't matter how you authenticate it to the system, basically. Of course, after a certain period of time, you can log out, or if you don't log out, the system will log out you automatically. Of course, if there is inactivity. Then versioning. The API also supports a versioning mechanism. We include the version number in the URIs. In addition to that, we include the version number in the schema namespace. And we require that everyone who is implementing the vCloud API support entry point which can show what are the supported versions for this server. In the example here, there is only one version supported. We include the version number in this response, which is the login URL, which is the entry point. Then some information about the model, what are the complex types, what are the media types, what is the XML schema. all this is supported by the versioning information that we return by the API. And the final feature that I'll talk about, this is the API extensibility. When we designed the API, we had several things in mind. That we wanted that a general client that is implemented for the vCloud API can work with a server that provides some extensions. And we want service providers to add, to be able to add their custom extensions to the API. But this should be done in a way that a general client can continue to work with the API. And there are multiple ways to extend the API. We can add new entities, we can add new operations, or you can add existing entities, including adding new OVF sections. With that, I believe that I finished with my part of the presentation, and I will ask my colleague Prasad to continue and to talk about the vCloud SDK. Thank you.
Thanks, Vasily. So let's start from why we need SDKs. When we actually take any APIs to the developers, the success of any API actually relies on how the developer community embraces the API. And it mainly depends on what are the tools available, what are the supports in the IDEs, and so on and so forth. And howsoever good the API is, it all depends on how easy the developer's life is around that API when they're using it. So that's one of the main motivation why we started with the SDKs. And we are aware that our users are ISV developers who will be using languages like Java, C#, administrators who will be using scripting languages, Perl, PowerShell, and so forth. If you think that there is any scripting language or any language that is close to your heart and it's not on this slide, join the community, let us hear from you, and then we will consider it. And don't be surprised that if I've already heard you without you saying it, because the work is in progress. We're going to spend a lot of time on the Java library. Why Java SDK? One of the main reasons is we trust in eating our own dog food. So we started with Java, and some of the VMware products are using this SDK internally in those product development. So we get the ready-made feedback from internal users. Another important thing is API is not just the protocols. API, when it gets into the developer's world, they expect a solid object model. And you just heard that in case of vCloud API, that object model comes from XML schema. Now, how many of you actually really like programming and parsing those XMLs in, day out? Any hands raised? I know there is always one hand here on my left. And trust me, actually, I can read XML schemas the way we read Java code. But for many people, it's no fun, primarily because they want to focus on their problem definition, their applications. And all these XML processing, HTTP processing, they want somebody to take care of. And we are just standing up to the plate and saying that, okay, we will handle that in the SDK. There's another big motivation of why we want to actually write the SDKs. We are going to make the REST resources available into your programming language, in this particular case, Java. And one of the things that we want to do is not hide the resources or the entity model that the vCloud API has defined, but provide you wrapper classes or utility classes and methods that can make the developer's life easy. You just saw that the vCloud API is compartmentalized. We have user API, admin extension. We actually reflect that into our Java SDKs by creating different packages. What are the design principles? When we started, actually, we set out certain constraints or principles for us that we will follow. One of the main thing is high fidelity to the REST API. We don't want to hide REST API by creating a new object model or wrapping all the resources and entities. Since you understand the REST API, you will keep using the vCloud APIs. All those objects will be available to you. So vCloud API defines the resources using schema, we will provide the schema bindings using the JAXP. So all those classes will be available to you as a Java classes, plus the utility classes. Simple, clean design. There should be a predictability. So if you are actually running certain methods, like get by reference, get by name on a particular object like organization, you don't have to go back to the Java docs to see how that same thing can be done on the different objects like VDCs and catalogs. We want to hide the XMLs and HTTP details from you and provide, again, I think I'm repeating myself, give the JAXP bindings for the usage. And some of the commandments that we actually wanted to follow is less is more. We want you to write less code, and whatever the boilerplate code is, we will suck it into the SDKs. REST model types are accessible to the clients. URL semantics will be hidden from you. Of course, there are certain entry point URLs that user will still need to know, but most of the URLs, how they are formed, they will be hidden by the SDK. How we actually traverse from a top level resource to its contained resources and so forth. That while doing that, you won't have to worry about the resource URLs. So let's quickly jump into how the Java SDK code looks like when you're trying to code for vCloud API. Notice that we are starting with the vCloud client. That's the SDK object. And it's actually using the versions URL. That's one of the URL that we saw in Vasil's presentation, that the backend tells you that what versions are implemented for the vCloud API. If you are behind the proxy, you can set the proxy onto the client and then do a get supported version. And then pick up a certain version information and say that, okay, this is the version that we are going to deal with, in this particular case, 1.0. And then do the login. Once you log in, what it returns is references to the organizations that the given user has access to. Let's not get into the complexity of the functionality of the code, but notice one thing, that we made a request using the version URL. We actually did a login. All of them were HTTP request and responses. Nowhere you are seeing the HTTP request response details. Nowhere you are actually dealing with the XML payload that came back as those HTTP requests. While doing that, another thing to be noticed is we are using the SDK objects, but at the same time we are using the objects that are defined in the API specification. In this particular case, that arrow pointing is to the reference type. Reference is a reference to the resource. In general, it will be a URL, but that's defined as a type in XML schema, and that's what we are using in our client-side code. Basically, what we are showing is you have an access to those objects defined in the schema, which are vCloud API objects and the SDK objects. So let's see what the user APIs or the vCloud SDK can actually help you do with the resources. A simple example, again, we are dealing with the SDK objects, organization object, which is a helper object created for you, catalog, which is a helper object created for you. And just above that, you can see that the reference type, which is coming from the vCloud API as a JAXP binding, is also available. The subsequent code actually demonstrates how you can traverse from the top-level object, which was an organization, right up to the client catalog items. So once you log in, I said you get a bunch of references. It's still not an organization object that you got. It's just a reference to the server-side resource. So using that helper object, which is SDK.organization, you are saying that get organization by reference and provide that reference to that helper method. And by executing that, you are getting the organization object. And to that organization object, you are then asking, give me the further details. Now, once you actually start playing with those API details, you will realize that the organization actually contains furthermore references to other entities. These entities will be the catalogs which are available in that organization, the VDCs, the users, the tasks which are there. You are not going to get all the objects. You are only going to get the references. And there will be a bunch of such references. lots of them related to the VDCs and tasks. The SDK will actually separate them out, and then you can go and ask, okay, give me a catalog reference by name or VDC reference by name. So these are the helper methods or the value addition that are provided in the SDK. Once you do that, you will actually go and further traverse that, let's say, catalog in this particular case, and say that, give me the items, because the catalog will only have references to the items, and then you will have to walk and get the access to the item object. Another thing to notice here is many things can go wrong when you're doing the HTTP communication, XML processing, and so forth. We are not exposing the SDK user to those exceptions. We are wrapping everything into the vCloud exception, primarily because we can actually change those libraries, and we don't want your code to be actually affected by that. That's one reason. This vCloud exception will also propagate the error type that you just saw in an XML. So if you want more details of what happened or what failed at the implementation of the server side, you can interrogate the error object that is provided to you along with the exception. One of the important thing when we actually saw the list of get, post, put, delete operation was an action to be performed onto the resources, and that's a post operation. But let's see how it actually happens when you're using SDK, because you are not going to actually do anything specific with the REST. You're not going to do anything specific with the XML. So again, we will traverse the organization. We will start with get organization by reference, and in this particular case, we will say, get us the VDC, because the VDC is your resource contained inside an organization. Once you get the VDCs, you want to know how many VApps are there. So VApps are part of the VDC. So you actually go and get the VApp by using its reference. Once you get the VApp, it's just like in any other object. You're an object-oriented developer. There is a Java object. You just want to run a method onto that object and say that power on, power off, deploy, undeploy, sort of things. One of the things that you can also notice is the predictability of the methods or the method names or the operations that you can perform onto those helper objects. So if you see organization, you will have get organization by reference, get VApp by reference, get VApp reference by name, and so forth. And when you are running that operation, just say VApp.poweron. So this is something that every user will end up doing. One of the example, and we started this session with, was how do we move our VApp or the workload from private cloud to the public cloud or within the public cloud. But one thing you have to understand is when you start, you're going to start with, let's say, an OVF. There is nothing in the cloud yet. You just have an OVF descriptor and a bunch of VMDK files corresponding to the VMs there. And how do we get that OVF or VApp into the cloud? 3 simple steps. You have to start or initiate the upload. Once you start and initiate the upload, we will create a representation for that VApp in the cloud. Now, the endpoint still doesn't know what's inside the OVF file till we actually upload the OVF descriptor. So that's our next step, to upload the OVF descriptor. Once we upload the OVF descriptor, now we know that how many VApps are there inside, or how many VMs are there in that VApp, how many disks are associated with each and every VM. So basically, once we upload the OVF descriptor, the backend will actually resolve all these things and say that, okay, now my VApp template, it looks like 2 VMs in it. Each VM has, let's say, 2 VMDK files or 2 disks associated with that. That's the next step. But now you have to actually upload all the VMDK files there. And when we upload the VMDK files, you have to make sure that the flag like OVF descriptor equal to true, so that all the resolution has happened, the backend has actually resolved, it knows what's inside the OVF descriptor and so forth. So many English statements, like, sounds daunting. Now let's see how we can do these things using SDK. And some of it is going to be just Java code, but focus on the SDK methods here. We create the type, which is upload VApp template parameter type, again defined in your schema definition, where we say, this is the name, this is the description. And then we go to the VDC helper class, the wrapper class, and say that create a VApp template for me. That's our first step. The moment we do that, a backend representation of the resource is created. After that, bunch of Java coding lines, get the file input stream, and just execute the helper method onto the template object that we actually got back, which is upload OVF file. You are done with OVF file. Now we have to actually upload the VMDK files. So once we refresh the object, which is a template, we go on uploading files one by one. The only thing you as a developer have to make sure that whenever you are providing the specific file input stream, you are actually telling that, okay, this is for the VMDK file number 1. This input stream is for the VMDK file number 2, and that's it. And that's all about the value addition of the SDK that's creating to make your life easy on the client-side programming. So let's take a quick look at the admin APIs. Some of the admin APIs or the main tasks that people will end up doing is create organization or create users, so that somebody like Prasad walks into a public cloud service provider, they say, okay, create an organization for Prasad. Or an organization like Pepsi, Coke actually reaches the public cloud provider. We create a new tenant, an organization for that particular customer. And that's actually made available by the API in the admin API part. And then we actually provide similar methods, helper methods, and classes in the SDK. How do we actually get the entry point to the admin API? We saw that when we did a login, we used the vCloud client. So to the vCloud client, we say that, give me the admin client, and then that becomes the starting point. Then we create an admin org object, sets all the names, properties onto it, and then say that admin client, at the bottom line, create the organization. So that's the entry point for the admin client. And this is where exactly you feel the details of an organization. If you actually see the UI for the vCloud Service Director, most of this information actually matches all the dialog boxes or the screens that you will end up filling into the UI. The user experience is same. The only thing is that's a graphical interface. Here is your programming interface. It almost matches exactly. You fill in that information. You run that API method, object method, and there goes your organization that's created for you. Once the organization is created, the standard administrative task, create user. And again, you create the user type, follow the details of what the user information is, and then tell the admin organization object that create a user. That's an object-oriented programming. You are saying that the new user that gets created is going to get created in that admin org object that we just created. So that was part of the admin API. The next one is the admin API extension. Again, the story goes the same. You have an API, you get the SDK classes, you get an entry point for the admin API extension as well. In this particular case, you start with a vCloud client saying that give me the vCloud admin extension, and that's my entry point. What do we do with that? We create the external networks, we create the provider VDC, we create the network pool. These are the certain administrative tasks that any service provider will be doing whenever they actually stage the vCloud environment. One of the important things that they will end up doing is they will have a VC infrastructure there. They want to actually move their vApps from their virtual center into the cloud. We have an API for that. We have an extension API for that, which is get the vApp into the cloud as a template or as a vApp as it is. There you go. Your vCloud admin client will provide you those particular methods as import VM as a vApp, import VM as a vApp template. Basically, you are just moving your VMs or vApps from virtual infrastructure into the cloud. If you want to deal with VCs and resource pools, we have the provider VDC class. And this is basically will cover everything that your admin extension APIs are doing. Again, the names look similar, the method names look similar. That's the whole point about the predictability. You don't have to learn anything specific new if you're using the SDKs. Call to action. This is probably the end of the VM world. We have almost there. But let me go into the past. We had a lab. I think it's still there. I don't know what the timings are. And most importantly, the online resources and the community. So we have a community created for vCloud API. We have created a community for the SDKs. We want to hear from you. Most importantly, I know you will say what you don't like. Everybody does that. We want to hear from you what you like as well, so that we can repeat these type of things. Repeat these or continue to do this in the API, as well as repeat these things in the different SDKs as well. So participate in the API and SDK community. Give us your feedback. If you don't see those languages, say about it. And I think we will open for questions. More importantly, survey. Give your feedback on the sessions as well. There are many people who would be interested in knowing whether you liked it or not. So basically, we are open for questions if you have any for next 10 minutes. Yeah.
What is the most advanced SDK for what programming language is the most advanced? Is there already one in Perl or besides Java?
So Java is GA. Oh, okay, sorry. Let me repeat the question. What is the most advanced SDK, or maybe let me put use other word. What is the most complete SDK which is available right now? Java is generally available, which was released along with the vCloud Director product. So we can say that that's most complete. But we have PHP and C# also on the line, so the beta will be soon out, so stay tuned for that. And other languages are also in consideration. I can't say about the timelines here, but they are work in progress.
Priorities on languages?
Priorities? Okay, so since we heard about it, we will raise the priority of the Python. But yes, it's also Python is also work in progress. Don't be surprised if it comes earlier than you expect, because it's happening. I just can't say about the timelines. Okay. If you don't have, okay, one more question.
Earlier you said that you didn't like lumping the URLs. So if there's some kind of version that, like, for example, I want to be able to bookmarks current up and on of my VMs, is there any guarantee that this URL is going to change?
Okay, so for the record, let me just repeat the question. We decided that we are not going to expose the URLs. So if somebody wants to actually bookmark the URLs, which is, say, specific to power on-off of a VApp, how do we handle that? Let's take this from the API point of view, and then we
from the API perspective, the URLs for given versions are they're guaranteed that they will not change. We include the version number in the URL, meaning that when you introduce a new version, the URL will change. But if you're within the same version, we don't give any guarantees how to, we don't give any receipt how to build the URL. But once you have the URL, you can reuse it for later, and you can cache it, basically.
So from the SDK point of view, now, since there is no guarantee that URL constructs will be the same, they are not part of the specification that it will be always like /a/b/id or something like that. We don't expose them to the users. But for all practical purposes, they will be the same in that implementation. But since they are not part of the spec, we are not giving access to the users for those URLs. But that doesn't mean that you cannot see them. you can actually look at the reference object, and you can see the property of that reference object, which is an href. That's your URL. That's exactly how the resource will be pointed to. But we recommend that you don't actually cache that thing as a good practice, because API says that it's an opaque URL. Is there a way to get VM? Can you speak to the mic?
Can you get statistics for virtual machines?
Using the API or the SDK? Probably we'll start with the API. Yeah, basically for the VM, what is as information what you currently can retrieve. This is the you can retrieve what is the VM, the memory, CPU, disks, etc. If you want to other statistics like running time, like network bandwidth and things like that, you can also do this using the vCloud API. There's another product, vCloud Chargeback, that we have, and you can do this through the vCloud Chargeback. And all these things are also exposed through the SDKs.
So the answer is same. If the API cannot do it, SDK won't do it, type of thing. But if this, as you said, if this statistics is for chargeback integration is there for the vCloud director, and that can be used. Okay, no hands are raised, so we will stop here. And if you still have questions, we'll be around, so just catch us. Thank you very much.